All right, welcome to today's mini tutorial. Today we're going to be talking about publications and subscriptions. So publications and subscriptions are part of the value federate interface in Helix. A value federate is a federate that allows for communication of physical values and properties, and this is what publications and endpoints deal with. These are such things: voltage, current, power, control signals, any other sort of physical connection you might imagine, or any other sort of value-based data transfer you want to establish in Helix. And the communication through these federates is done through publications and subscriptions. Basically, publishers create data. This data gets sent to all the subscribers. So it's a one-to-N correspondence. There's a single publisher, and there can be many different subscribers in different federates all throughout the entire federation. There's a couple different APIs in Helix for publications. The one in valuefederate.h, or HPP, is you register a publication with a name, a type, and units. And these are basically strings. So the global name that gets published throughout Helix is normally the federate name with a separator followed by the name given here. There's also a register global publication call. And this basically doesn't prepend the name with a separator to it. And from these calls, you get an identifier back. And this identifier is used in all the publish calls or any other calls that require a publication ID. There's also templated variants, so you can specify a specific data type with that's valid in C++ with these calls, and then you just need to supply a name and a unit. The unit in this case is also optional. There's also index variants, so if you have an array of federates and they all publish a specific thing, you can index them based on the indexing number, and this simplifies naming somewhat. We haven't used this too much yet, but it's used in a few of the examples. The type is basically an arbitrary string. There's a number of predefined types based on kind of data classes in C++. And these are checked with publication. So if you create a publication with a specific type, and then you create another subscription with another very different type that is incompatible, this will generate a warning. Units are also user-defined strings. They're not really used in the core of Helix. They're just available and transmitted throughout the system. They're intended to be used by higher-level APIs for unit translation or other purposes if they so choose. Subscriptions are added similarly. They generate a subscription ID. You can add optional subscriptions which do not check if a publication is actually generated, so it can mean there's nothing publishing to that subscription. And a required subscription likewise generates an error or warning if the matching publication is not found by the time the federation enters the initialization mode. There's also indexed and templated variants. In most cases, the type and units here are optional. There's also helper functions available for publications and subscriptions. You can get the ID back from a name, or get a name from an ID. You can also get the units and types. You can also set callbacks for subscriptions. So when data is published and updated, this callback will be triggered, and this is triggered just before the returning from the time request call. And the order of the callbacks is by the publication ID or subscription ID. To publish, you basically call the publish function of a federate with the identifier given from the generate or the register publication along with a value. The value here can be templated. There's a number of different options available. You can send it a raw pointer with a size. You can send it a string, constant char, or a data view object. And data view is basically a nice wrapper around a pointer and a size. And it has a number of constructors which can take data from a number of different data types which you may want to send data in. And it's very similar to the string view object if you're familiar with that. The time registered with the publication is basically the most recent granted time to the federate. To get values, you call the getValue function. This can be called with a type, so you can actually get a value of a specific type. There's two different variants of that. One returns, one takes a reference and updates that. These are all templated on the type of value. The data view, you can get a specific data view object. This is basically the raw data that came through Helix. Subscriptions, you can also set a default value, so if there's no update, if no update has ever been received, so this is basically the initial value that gets returned, and you can check if it's been updated and get the time of the last update. There's also a publisher and subscriber API. These define individual objects for the publications and subscriptions. They support a number of well-defined types. These types include double, 64-bit integers, strings, vectors of doubles, vectors of complex numbers. This is not supported in the C interface. You can also do complex, and which is also could be thought of as a pair of doubles. And we're working on support for a named point. And this is an object which is basically contains a string and a double, is the same thing. So a publisher has a specific type associated with it, and this type defines how it gets transmitted into Helix. The object itself, you can actually send it data in any one of the supported types, or any one that's easily translatable to one of the supported types, and it actually makes the best effort to do the internal translation. I'll get a slide that shows kind of how things get translated here shortly. You can also use a minimum delta associated with it. So if you're sending a double value, you can specify how much change in the previous value you need to actually transmit. And this can simplify things if you're actually using an iterative interface. And then it doesn't actually publish the value unless it has changed by a certain amount from the previously published value. So this is a map, a matrix of the type translations. The ones in green here are basically you can do a round-trip transfer between them. So if you start with a double, it gets translated to a vector in the middle. Then it is interpreted as a double on the other side. That represents no loss of information. So all the ones in the green here, you can translate to and from the column on the left here. So if you start with a double, that gets translated to doubles, vectors, strings, complex numbers, a complex vector, and a named point. And then on the other side, you can get that value out as a double with no loss of information. The other ones here, there's some translation functions. For instance, a vector will basically come up with the magnitude of the vector. And in the case of integer 64s, there may be a truncation as well, so it truncates off the decimal part of that. And you kind of see how this plays out. So while all translations are available, some are not necessarily wise. And in the case of integers, mini doubles are easily translatable, particularly lower numbers. So if it can be represented in a 52-bit number, this can translate to a double. And that's based on the binary representation of a double. Subscribers also support types. Values can be retrieved as any type that's specified, and anything that can be easily translated to this. So if you want to get an integer out, it'll translate that and truncate it from an integer 64. You can define a type if you want it to warn for this, but it's not necessarily required. And the object itself can extract to any supported type. And this kind of covers what I've done before. There's also a specification that allows a minimum delta to update, and so this will not actually update the value if it hasn't changed. This is basically a similar function to the publication side. There's also callbacks available. These publisher and subscriber objects form the basis for the C shared interface, and they can basically free different federates from having to match formats. So you can publish, say you want to publish actual numerical values from one federate, but the other side can only interpret them as strings. You can do that pretty easily through these publications and subscription objects. Or one may not support complex vectors, but if you just want to get it as a regular vector and reinterpret them as complex numbers, pairs, you can do that and mix and match through this kind of interface. Eventually, the hope is to support limited unit translations as well. This will require some effort on the domain-specific APIs that are in progress now, and standards are hoped to come out in the next couple months. And that's all I have, and I'll take any questions on publications and subscriptions now.
Hey, Phil, this is Himanshu. So when we are subscribing to something, let's say to a voltage at a bus, does it get tied to a particular fed rate, or we're just subscribing to the voltage, or is it voltage from a particular fed rate that we are subscribing to?
So each publication will be associated with a particular fed rate. The interfaces of a fed rate basically define what that fed rate does. So when you subscribe to something, you're making a direct link to another fed rate through Helix.
Okay. Okay, thanks.
Phil, this is Trevor Hardy at PNNL. Can you explain more what you mean by a named point?
So we were looking at some use cases for kind of control signals. And where one of the things that came out of this was that it might be useful to be able to tie a string with a numerical value. So say you have a publisher, it's basically publishing a set of values each, but there's a couple different points associated with it. So it publishes voltage, current, and data, and it just wants to do this through a single publication. That would be a use case for a named point, where you'd basically say what the value means associated with it. I could imagine some other use cases for it, but that was one of the key ones. The one other thing we are looking at is another type of interface that would allow multiple publishers to publish to a single subscription effectively. So this would be a new type of interface, but that's where you could send control signals to a fed rate. And that's where another use case of a named point. It's basically a string associated with a number.
Phil, this is Sri. One question, what is a good way to send and receive values of different types? So let's say if I have a few doubles, an integer, a Boolean. Right now, what I've been using is I've been packing them into a string and sending them out. So packing and then doing unpacking. Is there any other efficient way to do that?
Right now, I actually would just suggest making multiple publications. But we've toyed with the idea of actually making more of a well-defined structure type, which would basically allow for arrays or structs of the well-defined types. Still something we're looking at and haven't really worked too much with, but it's something we may need for the HLA support.
Okay, thanks.
All right, any other questions for Phil? All right, thank you, Phil.